Hi students, I am going to start exercise 7.3 introduction video. The introduction topic mean value theorem. Mean value theorem. Okay. Theorem 7.1 intermediate value theorem. Intermediate value theorem. If f is continuous on a closed interval of a comma b. F is a function. The function is continuous on a closed interval of a comma b, and c is the any number. C is the any number between f of a and f of b inclusive. Then there is at least one number x. At least one number x in closed interval of a comma b such that f of x equal to c. F of x equal to c. Okay, so the intermediate value theorem is closed interval of a comma b is a continuous now such that f of x equal to c. Then next theorem 7.2 Rolle's theorem is a very important statement. Let f of x be continuous on a closed interval a comma b. F of x be continuous on closed interval a comma b. A and b is in between the value of function f of x and differentiable on the open interval of a comma b. Open interval of a comma b. The differential on the open interval of a comma b. If f of a equal to f of b, then there is at least one point c belongs to a comma b where f dash of c is equal to 0. Okay, so see the now Rolle's theorem. F of x is a function. Now f of x is a function. Now f of x is a continuous, and f of x continues in closed interval of a comma b, and f of x is a differentiable of open interval of a comma b. First point is a continuous, second point is a differentiable, and third point is a value of f of b equal to f of a. Okay, so now in this condition or three conditions are satisfied, f dash of c is equal to 0. F dash of c is equal to 0. So now to find the value of c belongs to a comma b. C belongs to a comma b. Okay, so three conditions are satisfied is the theorem of Rolle's theorem. Okay, so now the Lagrange's mean value theorem. The Lagrange's mean value theorem. Theorem is 7.3. Let f of x be continuous in a closed interval of a comma b and differentiable in the open interval of a comma b, where f of a comma f of b are not necessarily equal. Then there exists at least one of the points c belongs to a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. Now f of x is a function. First point is the value of f of x is a continuous and closed interval of a comma b, and the second point is f of x is a differentiable open interval of a comma b. Now third point, f dash of c is equal to f of b minus f of a divided by b minus a. So in this three conditions are satisfied now is a Lagrange's mean value theorem. Okay, so next one, theorem 7.4. If f of x is continuous in a comma b and differentiable in a comma b in open interval of a comma b if f dash of x greater than 0 for every x belongs to a comma b. Then for x1 comma x2 belongs to closed interval of a comma b such that x1 less than x2 we have f of x1 less than f of x2. Okay, so f of x is a continues in closed interval of a comma b, and f of x is a differentiable in open interval of a comma b. Then if f dash of x greater than 0 is for every x belongs to a open interval of a comma b, then for x1 comma x2 belongs to closed interval of a comma b such that x1 less than x2 we have f of x1 less than f of x2. Okay, that's all. We will meet the next class.